Hello everyone, you are listening to Abhishek Jain, the founder director of Yasi Global. Yasi Global has been working in the field of student motorsports for the last 8 years. We provide all kinds of trainings, workshop solutions, and manufacturing solutions to the student teams planning to participate in any kind of student motorsports event in India or internationally. So if you are a part of any student motorsports team participating in any kind of student motorsports event, be it the go-karting event, the Supra event, ATV event, quad bike event, solar event, e-bike event, feel free to reach out to us to get the consultation as well as to get the complete solutions of trainings and manufacturing solutions. So thank you so much if you have joined up with this particular video. We have launched a particular series on Formula Student, that is the teams which are participating or planning to participate in any kind of Supra or Formula type of event. So this is a very basic or the essential thing which I particularly believe students should have to go through to have the bare minimum understanding of what is required to start designing the vehicle. The approach that you people need to have while developing the complete set of instrumentation or to complete set of parameters required to design your vehicle. Apologies, I was supposed to take this particular lecture on 28th of April. That was a live session. I was not able to take the session at that time, so today I'm uploading this particular lecture. In continuation to this series, today at 8 p.m. we will be launching another lecture on transmission system, which is going to be helpful for the student participating in the combustion category of any type of Formula student or any type of Supra event. So let's dwell deeper into this particular subject now. Thank you so much if you have joined up with this particular video. I want you to stay here for the next 1 hour with me. Be very patient as we are going to deal up with all the content that is required to design the suspension system for a Supra vehicle or the Formula type of vehicle. Okay. So up till now, we have discussed about that we have got two lectures earlier. First, we discussed about the chassis frame design. How do you people need to target designing your chassis frame? I discussed about the very fundamental, the entire approach that is needed to be followed up. In my experience, what I found out that usually the student teams do not know where to start with. You can find out n number of research papers on internet, n number of team reports on internet of what they are doing, how you can implement this particular instrumentation in your vehicle. But at the end of the day, as an engineer, you should know the exact approach. How did you reach there? How did you get to know that you want to use a particular set of gearbox in your vehicle? Okay? And if you do so, you will find out that vehicle is not a dedicated entity, but the vehicle is the integrated entity. Vehicle is the integration of different subsystems like the steering system, braking system, suspension system, transmission system. And when you're going to integrate all these systems together, there are certain compromises that one system is going to make over the other. And you need to focus on that particular compromise as well. Right? Now, say for example, if I start designing the chassis frame, someone from the suspension team, someone from the steering team comes up and says, this is not how you're supposed to design the chassis frame structure. You need to start making some changes on the basis of how we are designing our system. And if you start making these changes without having a set of logical order, then what will happen? You will get into the endless loop of not understanding of what exactly is needed to be done at the very first place. So with this particular series, I'm just trying to break it to you the entire process of designing. Please remember this one thing, that designing a vehicle is not the absolute phenomena. It's not just about I'm going to give you a problem statement, you will be having some formula and you will get the exact statement of answer. It's not going to work out in this way. It's a continuous iterative principle. It means once you design the chassis frame structure, it is going to be iterated on the basis of some other subsystems design, right? But now, as you know, one subsystem is also associated with any other subsystem. Then how will you do that? So for that, there are certain principles that are needed to be inculcated with the design of the vehicle. I would recommend you people to go to the lecture 2 of this particular series. You will, lecture 1 and lecture 2 of this particular series. You will get the understanding of what I'm actually talking about. So let's move ahead. In second lecture, we discussed about the steering system. Again, when I say that we discussed about the steering system, we just discussed about the very basics of the steering system that are required to be understood. Okay, I have talked about the kinematic process. Like you do not need to inculcate the effect of force, inculcate the effect of any type of movement that is acting on your vehicle. Just on the basis of geometrical approach or just on the basis of kinematic approach, if you would have been given a target to design the steering system, how would you do that? Okay, so with this, you can have this clarity, you can have this understanding that if you have been given a target to design a complete vehicle, you need to start designing the complete vehicle from the kinematic approach. As a student team, you've got a hell lot of time to work on all the basic structures of designing the vehicle. And I want you people to go through the entire journey of developing the vehicle because it will give you the complete understanding of why this particular phenomena is being done in your vehicle. Okay, why you are using this particular subsystem or this particular system in your vehicle. Let's move ahead. So today we will be discussing about the suspension system. What do we actually mean by suspension system? So before we move to the entire chronology, it's very important and imperative for us to have this understanding of what do we actually mean by suspension system. Now, as the name suggests, suspension, anything that is responsible, any system that is responsible to suspend all the items of a vehicle over the ground is regarded as the suspension system. Okay, other than the reactional surfaces. Now, in my vehicle, if you look up into any kind of vehicle, my dear friends, you will find out there are only four reactional surfaces. If I'm talking about four-wheeler, you will find out reaction. It means these tires. Okay, only these tires are responsible to have the reactional force on the ground. Okay, so this is my ground. This is my tire. See, this is in contact with the ground, with the ground. So it is going to have the reactional force. Okay, so I can say in my entire vehicle there are only tires which are in a reaction with the ground. We got this thing. Only tires. So other than the tire, everything that is suspended together over the ground, okay, and the system that is responsible to do so, that particular system is regarded as the suspension system. So you can say the very first thing in your vehicle is the tire, and your tires are the sole responsible members to make sure, or are the most prominent members to make sure that everything in your vehicle is over the ground surface, and they are the only their sole reactional surfaces with the ground. Okay, there are sole members that are making reaction with the ground. So can I say that my tires are the part of suspension system or can be regarded as suspension system? Yes, my dear friends, your tires are also a part of suspension system. But the only thing is, if you look up into the very fundamentals of vehicle, you will find out why do you use tires in your vehicle. You do not use tires in your vehicle because you want the complete mass to be raised up over the ground or you want some other function to happen. You only use your tire because these tires are responsible to move you forward and move you backward. Right? These tires are responsible to move you over the ground surface. That's why you are using it. It means the primary use of the tire is not the suspension. The primary use of the tire is into transmission, my dear friends. Okay, is into transmission system. So we got this thing. So I can say the tires are part of suspension system, but primarily their primary role is not to act as a suspension system, but to act as the transmission system. So I can also say that if I categorize my suspension system in two categories on the basis of their usage, you can say there are two kinds of suspension system. First is the active and second is the passive. Active is the direct one. You are using this particular system because you want it to act as the suspension system. You want it to act as a system which is going to carry all the items over the ground surface. And the passive whose primary role is something else, but it is also secondarily or tertiary, it is also acting as the suspension system. So my tires get into the category of passive suspension system, but not in the category of active suspension system. Everyone, please understand that I'm trying to get you, I'm trying to make you people understand the very basics of designing the vehicles. And it is really very important for you people to have this clarity and have this understanding as well. Let's move ahead. Okay, so after the discussion of the tires, I can also say that my chassis frame structure, right? My chassis frame structure is also responsible. My chassis frame structure is also responsible to keep everything over the ground surface. So can I call my chassis frame structure to be the suspension system, to be the part of suspension system? Can I say this thing? Okay. What is the primary function of the chassis frame system? In the very first lecture, we discussed about this thing. I will be making a separate playlist for the Formula Student type of vehicles. You can just check out the very first video here on the chassis frame. I believe we had the discussion on 15th, oh sorry, on 14th of April. If you look up in here, you will find out the primary function of the chassis frame structure is to integrate all the subsystems of the vehicle together. Okay, including the ballast area where the driver is going to be seated, your entire area where everyone else in your vehicle is going to be seated, the passenger gate area, the luggage area, boot area. So a system or a part which is responsible to integrate everything together. Your suspension, your steering, your transmission, your braking, your ballast area, cockpit, everything is going to be integrated together on a certain frame, on a basic frame. And that particular frame could be the roll cage, could be just the ladder frame structure, but it's regarding the chassis frame structure. Okay, so the primary function of the chassis frame structure is to integrate all these subsystems together. Its primary function is not to hold you over the ground. Okay, so you can also say that my chassis frame structure is a part of suspension system, but still the passive system. Passive suspension system. We got this thing. Okay. So what do we actually mean by the active suspension system? When you go to the marketplace, you will find out in some rickshaws, or if you look up into go-karts, you will find out these go-karts does not have some separate springs or shockers. And primarily, whenever we talk about the suspension system, we used to believe that a set of shockers, or a set of springs, a set of dampers are going to be considered as the suspension system. You are right, but not absolutely correct. So it's like you know that this is the suspension system, but you do not know the real basics. Why this is regarded as the suspension system, or is there anything else that can also be regarded as the suspension system? So, say for example, if I'm using anything very specific just for a single use, that its only use is to keep everything over the ground surface, then you will be regarding it as the suspension system. So, this is my tire, this is my frame, and now my tires and my frames are connected with the help of a shocker or with the help of a spring. Now, there are two functions of this spring. Okay, the very first rule is to keep everything upright. Okay, everything over the ground surface. First, second is to cause a relative motion between tires and chassis frame. Okay, what type of relative motion? Transverse relative motion. Okay, vertical relative motion. So you can say that whenever I talk about this kind of suspension system, this kind of thing, it is actually regarded as the active suspension system. So what is suspension system? Anything that is responsible to hold you over the ground is regarded as a suspension system. But when there is anything that creates the relative motion between the tire and the ground, tire and the chassis frame structure, then it is regarded as the active suspension system. Please remember this one thing. But why do we require active suspension system? The question comes up in here. So let's look up into this particular thing in detail. Now, say for example, this is the kind of road that I have done. So this is my vehicle. Hmm. This is my vehicle. So say for example, if I am seated here. Say for example, if I am seated here. I am moving forward. So if I am moving forward and suddenly say for example there is no spring, just a solid connection. Okay, just a solid connection, no spring. And when I am moving forward, suddenly a bump came up. So when a bump came up, what will happen? My front tire, okay, it will come here. My rear tire will stay here. So what will happen in actual? You will see that my vehicle would be aligned in this particular way. It will be tilted. Earlier I was seated onto this particular height, at a height of h. See, earlier I was seated at a height of h. But now, because of this bump, my height and my inclination changed to h plus delta h. H plus delta H. There was no spring. Okay, this is just a solid connection. Usually, what you look up into go-karts, what you look up into rickshaws. Okay, pedal rickshaws. This is how your position will change. Okay, this is how your position will change because your tire is just acting up with the terrain. It's just creating the reaction surface on the terrain. It cannot create a relative motion. So your height changed. And when your position, your height, your inclination changes, it actually creates a force on your body, a moment on your body. Okay? Which creates a force on your body. This particular thing creates a force on your body. So for example, I'm moving forward, I'm just riding a bicycle which does not have any kind of suspension system, and suddenly I hit a bump. When I hit a bump, all this force is going to be transferred on my body. All this force is going to be immediately transferred to my body. Okay, if I do not want this thing to happen, what do I need to do? I need to create a relative motion between my tires and the vehicle. Why this force is being acting on your body? We know this thing force. Whenever we talk about a force, it means your position is going to be changed. So your position is changing. That's why this force is also acting on your body. You can say this thing in a way. If your position is not going to change, then what will happen? The entire force will act in the more contrast way on your body. So what we will be doing in here, let me just remove it and write it down on the same page. What if I will be having a road, again my driver is seated here on this particular height, but this time I'm using the suspension springs. Okay, now there is a bump. Now as soon as my vehicle hits this bump, what will happen? What the suspension springs assure? What these springs assure? It assures that the height of this vehicle, always remains same. So this spring will compress and this spring will expand, and the height of my driver will always remain same. Will always remain same. This spring will compress and this spring will expand. Now there are also chances, my dear friends. See, if this height is way too high, this particular bump height, the first diagram, if the height of bump is way too high, then what will happen? There are high chances that the rear tire will also rise up. Rear tire will also rise up from the ground. If the rear tire will rise up from the ground, it means it will not maintain the required traction between the road and the tire, hence making your vehicle unstable. So here you can see, because your springs are compressing and expanding. Okay, front spring is compressing, rear spring is expanding. What is it doing? It is making sure that the height of the driver remains same, hence making your ride smoother. But when this thing is going to happen, my dear friends, you will find out your tire will be moving over a bump, your spring will compress, it will reflect back, and this will take some time. And if it will take some time, it means this particular thing will reduce your performance. When I say performance, it means your overall speed, your overall acceleration, time taken to cover the track will also be reduced because the suspension spring will compress, the suspension spring will come back to its position. The most important thing for the super student teams is not just to look up into this particular phenomena. In the case of bumps and group, it is going to help you maintain the ride height, it is going to help you maintain the center of gravity height. But what more important for you people? In the case of bumps, in the case of groups, or in the case of corners, whenever one of the tire is required to move up, your tire is going to lose the traction. Your suspension will make sure that your tire always remains in contact with the ground and does not lose the traction, hence making your vehicle stable to any riding or driving condition. Okay, so for student teams, for supra student teams, former student teams, please make sure your primary target of having the suspension system is to make sure that you always maintain the required traction in your vehicle by making sure that the tire remains in contact with the ground. At the same time, that whenever you are going to take the corner, you need to make sure that your center of gravity height or a center of gravity position is not going to be disturbed, is not going to be changed beyond your capacity of control. So I will be discussing this thing, what do I mean by the capacity of control here. My friends, please make sure that ARC Global provides all kinds of student motorsports trainings, and along with that, other than the team workshops, the group workshops, we also have individual internship and training programs. So we have got 30 days internship and training program on electric vehicle design. We have got 30 days internship and training program on automobile engineering. Okay, we have got 30 days internship and training program on CAD, on CAE. All these programs comes up with four independent modules. Four independent modules. Every Monday we start a new batch. So for example, if tomorrow onwards you join our automobile batch. So there are going to be four modules. In the first week, you will be studying about the fundamentals of automobile. Every single part that is required to construct an automobile, we are going to discuss those parts in this fundamental series. So that in the marketplace, when you look up into any vehicle, you would be able to realize, you would be able to understand what kind of engine is this vehicle using, what kind of power transmission system does this vehicle have, turbocharger, supercharger, everything that is required to construct a vehicle, you will be having that particular clarity and understanding. In the second week, we will be discussing about the basics of vehicle dynamics, and moreover, you can say how do you integrate these systems together. The law that decides the integration of these systems together, you will be studying about that. In the third week, you will work on the implementation, that is the CAD of the automobile. You will be designing the hub, you will be designing the knuckle, you will be designing the chassis from structure, you will be designing maybe the gearbox, so that you will have this holistic understanding that if you have been given this target to design the automobile, you would be able to have that confidence of not just solving the equations to get the answer, but also to replicate it on your CAD tool. Fourth, CAE. You will also have this understanding of how to analyze it, how to develop a better vehicle, and really making sure with the help of certain simulation processes that you have developed or designed a better product. Same goes for the EV. For the CAD, we will be having a complete holistic program for CAD. We will be discussing about the sketching, we will be discussing about the part design, assembly, and a dedicated capstone project. In the CA, we are going to do the same. 30 days, 4 weeks, 4 different modules. You will be getting the certificate of internship from our company. You will be getting the certificate of training from the company, and you will also get the certificate of project completion, which is applicable that if you would be able to complete the project or not on time. You will be getting these three certificates, which will help you out in making a better CV as well as having the better industrial exposure. So if you are a final year undergraduate or if you are someone who is interested to do this particular internship program, feel free to contact me on 8800 219620. Drop me a message on WhatsApp and I will let you know how you can join this particular program. Thank you so much. Let's move ahead. You can also think of joining us on Instagram. We have already reached more than 1,000 followers on Instagram. We are planning to come up with some knowledgeable reels in future. We are still planning on this thing. We just need to come up with the content for you people. So please follow us on Instagram. It will keep you updated with all the coming workshops, with all the coming sessions of our company. Let's move ahead. So I just told you why do you require the suspension system in your vehicle. So let's dwell deeper. Active suspension system. Now, when you're going to design the suspension system for your vehicle, what all parameters that you people need to remember? What all parameters that you people need to work on? The very first thing is that you need to develop a kinematic model. Kinematic model. Now, what do we need to do with the active suspension system? I need to generate the relative motion between my tire relative motion between my tire and road and ground. The relative motion is needed to be generated. Now, if we know this thing, if I look up into the top view of the vehicle, this is how vehicle looks like. Okay, this is how vehicle looks like. So now see, the axis that is passing from front to rear or rear to front is regarding the longitudinal axis. The axis that passes from sideways, right to left or left to right, is regarded as the lateral axis. The axis that goes from top to down is regarded as the transverse axis. Okay, now any motion, any movement, if it is acting on your vehicle, any force if it is acting on your vehicle, it will act along these three axes, right? It will act only along these three axes. This is how we do it for the ease of our calculation, for having certain references to solve the numerical statements. The forces that are acting along the longitudinal direction are divided into longitudinal forces. What these forces are, you will find as the traction forces. The forces that are acting between the tire and the ground in the front to rear or rear to front direction is regarded, these forces are regarded as the longitudinal forces. What these forces are? Acceleration forces, right? And the deceleration forces, right? Altogether, I can say the longitudinal tractional forces. Fractional force. Okay, if someone is pushing my vehicle, again, this is the longitudinal force. But now this time, this force is not acting on the center contact, but it is acting on the center of gravity position. Okay, center of gravity position. The aerodynamic forces acting on your vehicle, again, these forces acting on the center of gravity of the vehicle, but not on the tire center contact patch. But all these forces are going to be regarded as the longitudinal forces. Now, similarly, lateral forces. So, if someone is trying to push a vehicle from sideways, this is a lateral force acting on the center of gravity. And say, for example, if I'm trying to turn my vehicle, if I'm trying to corner my vehicle, we have discussed about the differences between the turning and cornering in the last lecture, in the steering system lecture. Okay, so when you're going to corner your vehicle, when you're going to turn your vehicle at that particular point of time, you will find out the reactional surface, the frictional surface, the frictional force between the tire and the ground acting in the lateral direction into this opposite direction of your corner. Into the opposite direction of your corner is also the lateral force acting on the tire center contact patch. Wherever it is acting, but its impact is needed to be considered as the tire center contact patch. Please remember this one thing. Okay, now similarly, if I talk about the transverse force, whenever any bump comes up or any droop comes up, it will cause the transverse force, the vertical force on the tire center contact patch. Okay, this is the transverse force or the vertical force. Now, here when you look up into this particular figure, my dear friends, you will also analyze, you will also understand that along all these three axes, there are certain movements that are acting along them. That is, the movement acting along the longitudinal axis is regarded as the rolling movement. Rolling movement. Okay, so whenever I am accelerating, so whenever I am cornering my vehicle, the weight transfers from the right side to left side or from left side to right side. Okay, from the inner wheel to the outer wheel, what is happening? The weight is transferring along the longitudinal axis, that is the rolling movement. Or when you simply moving a vehicle onto the ground surface, you will find out because the surface irregularities, there's a constant shuffle, there's a constant motion that is happening from right to left and left to right, right to left and left to right. That is known as rolling movement. That is known as rolling movement. Okay. Now I'm moving my vehicle onto the ground surface and suddenly I applied the brake. When I applied the brake, the weight transfers from the rear shaft to the front shaft, from the rear axle to the front axle. Okay, I can see that my body is moving forward whenever I apply the brake. Or whenever I accelerate my vehicle, I find out the weight transfers from the front axle to the rear axle. Okay, I accelerate my vehicle, I see that my body is shifting rearward. This is regarded as the pitching movement. Pitching movement. Okay, pitching movement. Now, whenever I'm turning my vehicle or cornering my vehicle, you will find out that my vehicle is pivoting along a point. Okay, it is rotating along a point, and that point, along that point, an axis passes through. An axis passes through, and that axis is a transverse axis or a vertical axis about which you have a moment regarded as the yaw moment. Yaw moment. My dear friends, you will find out of all these three moments, you have not provided the input for the rolling. You want your vehicle to move forward. You want your vehicle to corner. Roll occurred because of certain disturbances on road. Hmm. I want to accelerate my vehicle. I want to decelerate my vehicle. But pitch is the net outcome of the input that you have provided. But this is not what I desire. I just want to accelerate. I just want to decelerate. But this is something that happened. This is a byproduct of my acceleration. This is a byproduct of my deceleration. This is a byproduct of moving my vehicle on the irregular surface. It means the pitching moment is not the direct desirable outcome. Rolling moment is not a direct desirable output or outcome. These could be beneficial for your vehicle, but these are not the desired outcome. Okay, but only yaw is the moment for which you desire. We provided the input to have yaw in your vehicle. We provided the input to have yaw in your vehicle. So now pitching and rolling helps you at the same time also limits the parameters of your performance in the vehicle. How do we do so? And how does suspension play the effective role in designing your steering system or braking system or the transmission system in your vehicle? Let's look up into this particular thing. The suspension system is responsible for limiting or extending the pitching moment and the rolling moment in your vehicle. And that whenever I will be talking about the pitching moment and a rolling moment, see moment, if the moment is happening, it means it should have to occur through a pivot point. It should have to occur through a pivot point. So in this particular case, if I talk about the kinematic one, if I talk about the kinematic motion, I will be saying this is along the roll center. Each of these things is happening along the roll center, or which further creates certain set of instantaneous centers in your vehicle on the basis of motion. Okay, and if I talk about the dynamic, if I talk about the kinetic, if I talk about the forces, then it is the combination of roll center and center of gravity position. The weight transfer will always take place along the center of gravity, but the pivot which regulates the motion is the roll center. Pivot which regulates the motion is the roll center. So if you have been given this target to design the suspension system for your vehicle, my dear friends, the first thing that you people need to focus on is determining the roll center for your vehicle. What do we actually mean by roll center and how do we calculate this thing? So if I look up at my vehicle from front, if I look up at my vehicle from side, in both ways I can find out the roll centers of my vehicle. The swing centers of my vehicle about which my tires are moving up and down. My tires are moving up and down. So please remember this one thing, very important phenomena. Your tire does not move up and does not go down in a straight way. It's not just simply moving up and simply moving down. When it moves up, it creates a certain inclination like this. Okay, when it moves down, again it creates a certain inclination like this. Now, this particular inclination that you look up is being defined by set of virtual geometries. By set of virtual geometries. So there are four virtual geometries that have been identified in your vehicle. What these geometries are? Caster, camber, KPI, and toe. What do I mean by virtual geometry? This is how your tire is connected with the frame. How your tire is connected with the frame. And you can simply say, this is my tire, this is my chassis frame. So I have connected my tire with the help of seat, suspension, simple. But you must have noticed in some vehicles the suspension is inclined at a certain angle from vertical. From the side view, if you look up, that your suspension, now it's not just about the suspension, it's about which your tire is pivoting. Your tire is need to pivot to create the steering effort. To create the steering effort, your tire is needed to pivot. So if I view from the side, if I look up to my vehicle from side, how my vehicle vehicle's tire is set up with my chassis frame structure, at what particular inclination this particular thing is regarded as the Kessler angle. From the side, again, I'm going to repeat this thing because I do not want you people to have any kind of doubt in here. See, if I look up at my vehicle from side, if I look up at my vehicle from side, and this is the pivot about which I'm turning my wheel, I'm rotating my wheel, right, left. Okay, if this pivot, now about this pivot, you will find out in all the four wheelers generally, about this pivot, they also use the springs. Okay, they also use the spring because this is where your suspension is also active. So please remember, it is not about the inclination of the suspension, it is about the inclination of the steering axis, about which you are turning your tire, about which you are turning your tire. It is not just about the inclination of suspension, please, it is wrong. It is about the inclination about which you are turning your tire. This particular angle is known as Kessler angle. This particular angle is very much important because it creates the majority, it creates the most emphasis on the turning force, turning moment, or the cornering force that is needed to be applied to corner your vehicle. Gesture is the most important phenomena in your vehicle when you are going to design the suspension system or the steering system in your vehicle. Now, you must have noticed this thing in all the kinds of bikes. You always have the handle moving forward. Handle is a pivot point about which you are going to turn your wheel. Okay, moving forward. And that particular case is known as positive Kessler angle. In the case of bike, in the case of two-wheelers, you call it rake angle. In the case of four-wheelers, you call it Kessler angle. Okay, it is regarded as the Kessler angle, positive Kessler angle. Almost all the vehicles in the world have got positive Kessler angle, except some special purpose vehicles where we have got a negative Kessler or zero Kessler available. Generally, you will find out all the vehicles in the world have got positive Kessler angle. Okay, now your positive Kessler assists you in steering. Assists you in steering. How does that? How does it do so? By creating a reactional force, reactional moment to steer the vehicle. Moreover, it also helps in self-returnability of the steering. So you must have noticed this thing in four-wheeler that when you are going to turn your wheel, when you are going to corner your vehicle and you leave the steering wheel, it comes back to original position. Okay, it comes back to its original straight position. That happens because of the counter-intuitive steering force generated by the Kessler angle, which is very important in any vehicle. Now, if I look up at my vehicle from front, this is how my vehicle will look like. My suspension are going to be inclined like this. Okay, right? My suspensions are inclined like this. Now, when I look up at my vehicle from front, you will see this particular tire is absolutely vertical with the ground. Now, I'm talking about the horizontal surface. Horizontal ground surface. If this particular tire is absolutely vertical to the ground, I will say that it is having zero camber angle. Zero camber angle, right? So this is the center of the tire, this is center contact point. You can see this is tire is absolutely straight. But if my tire is inclined a bit inward, or if it is inclined bit outward, bit inward or outward, if it is inclined inward, I will be calling it negative. I will be calling it negative camber angle. If it is inclined outward to the frame, I will be calling it outward to the frame. I will be calling it positive camber angle. Now, Castor angle, camber angle, these are the geometries on how the tire is connected with the chassis frame, and they are very important. So, camber is very important to maintain the overall stability in the vehicle. Overall stability of motion is usually the phenomena of your camber angle. Is the front view geometry. This is how you do it. Now, my dear friends, why I said this thing overall stability? We know this thing, stability of the vehicle depends on that how much control, maneuver control you have on the vehicle, how much maneuverable the vehicle is. That I want to stop my vehicle, it stops. I want it to move left, it moves left. I want it to move right, it moves right. I want it to move straight, it is moving straight. I want it to move having a jump, it bump, it is having a bump. It is how maneuverable your vehicle is. Say for example, if I say the maneuver index of my vehicle is 100% to a limit of 40 kmph. It means up to 40 kmph. I want my vehicle to stop within a distance of 3 meters. This is stopping. I want my vehicle to move exactly 14 degree left. It moved exactly 14 degree left. I want it to move exact 16 degree right. It moved exact 16 degree right. I want it to accelerate at a certain rate. It is accelerating exactly at that particular rate. It means 100% maneuverability. It means you are thinking and it is responding in a way. Okay? It is reacting in a way. You provide the response, it is reacting in the same way. But after 40 kmph, this changes. You say now, when you want a vehicle to move by stop at a distance of 3 meters, it depends on the condition. It could stop at 4, it could stop at 2.5. You cannot control it. You can only know the limit. I want to stop in 3 meters, but it can stop within a range of 2.5 to 4, but not exactly 3. It could, but not exactly. I cannot guarantee. I want my vehicle to turn by 14 degrees, but it's not exactly turning by 14 degrees. It can only corner between a range of 11 to 17 degrees. Now, this thing is changing. So it means I can say the maneuver index became 70%. At a very high speed, say for example, I'm moving a vehicle at a speed of 100 kmph. You will find out at that particular point of time, you believe that you do not have much control over the vehicle. When I say that you do not have much control over the vehicle, what do I mean by that? It means that I am planning that I want to move my vehicle at a certain speed, or I want to have a certain acceleration in my vehicle, but it is not responding in that particular way. It is either having the higher one or it is either having the lower one. I want my vehicle to turn by this particular angle, but now my turning angle increased, my cornering angle increased. So now these things are not under your control. It means the maneuverability is being reduced. And my dear friend, the entire maneuverability depends on the relationship between the tire and the ground. Higher this contact, higher is the maneuverability. Lower is this contact, lower is the maneuverability. This is not 100% true, but this is something that works for majority of the times. The relationship between the tire and the road, how stick they are together. Okay, you must have seen this in the vehicles topple down, the vehicles roll. Why do they topple? Because the tire and the ground were not able to maintain the contact, were not able to maintain a particular relationship. So, if you are going to have the negative camber or the positive camber, what will happen? Your contact touch with the ground is going to be either reduced or is going to be either increased. So with the suspension system, with how you are going to use the suspension system on your vehicle, you will be making sure that your contact patch with the ground is always going to be having the stable zone. Is always going to stay within the stable zone. Within the stable zone. So you must have noticed this thing in some auto rickshaws. When you look up to their rear tires are actually inclined outward. And then when the passengers are being seated, the rear tires come back to their original position. Okay, it means at the time of no load, at the time of lesser load, the contact with the ground and the tire is less. Okay, but when there is more load, it means we need more stability, we need more maneuverability, more contact patches required. Okay, this is a very layman term language, my dear friends. When you go to the literal meaning of these things, this cannot go 100% true, but when you solve it, you will find out it works for majority of you. For most of the data, this is how it works. I'm leaving it to your consciousness, I'm leaving it to your wisdom, how you interpret these things. I want you people to go through certain books. Okay, so go to your chapter of suspension system in Carroll Smith. To understand how roll center and how this motion of tires and the transverse motion of tires are being interpreted. Go through fundamental of vehicle dynamics by Thomas Gillespie. Go through suspension chapter, go through ride chapter, go through road chapter. Just read these chapters in the book. Suspension is steering right. Go to these two chapters in there. You will get the understanding of how the suspension system is ready to be designed. I would recommend you people to go through medical and medical and again go through load chapter, go through suspension chapter, go through string chapter of medical and medical to have this understanding. Okay, so this is how you are going to target these things. Okay, now if I look up at my vehicle from top view, if I say both of these tires are inclined inward, then I will be saying this is toe in, which analysis of causes the straight line ability. Okay, toe in. If both of these tires are inclined outward like this, then we will be calling it toe out. Toe in and toe out phenomena are generally observed in captors. Yes, even in your vehicle you can have it. We generally say that toe is the compensating geometry. That if there is anything that goes wrong with the front view geometry or with the side view geometry, we have got toe to compensate it. Okay. Now we have got again the front view geometry where your tire is not inclined. Your tire is not inclined, but the pivot with which you are going to turn your vehicle. See, if this is the pivot, let me just do it again and maybe solve you. Say for example, this is my tire. This is the pivot about which my vehicle is turning, cornering. So if I just say this particular pivot is inclined from the front view. My tire is not inclined, but this pivot is inclined. Then I will be calling it the KPI. Kingpin inclination. Literal meaning of kingpin is anything about which everything rotates. Okay, so your vehicle, your tire is rotating along this particular axis. That's why I call it the kingpin axis. So this particular distance here, or if I say my tire is tilted but not this particular inclination, or this inclination is also tilted, say, then this particular distance from the ground, the tire center contact patch to this particular inclination, this particular extension of ground, this distance is regarding the mechanical trail, which is the next sum of camber trail and KPM. Okay, so even if my tire is inclined and this is also inclined, I will be getting the net KPI. Okay, now this is responsible to calculate the torque required to turn your wheel. Torque required to turn your wheel. If this value is very less, then your vehicle will become this particular trail is very less. If this particular trail is very less, your vehicle will susceptible, your steering is going to become susceptible to even a small irregularity on road. So even if a very small irregularity comes up, your vehicle will start turning, your vehicle will start cornering. If you do not want to do this, you do not want to have this in your vehicle, you should have to have a bare minimum value of this particular trail so that no surface irregularity can cause the steering input in your vehicle. Only your driver is responsible to cause it. So these are four geometries, and each of these geometries depends on how you are going to design your suspension system. Now, in the case of Supras, in the case of Formula type of vehicles, you use 4 by linkage mechanism and you use the independent suspension system. I'm not going to get into intricacies of all type of suspension system, but I'm directly moving up with the suspension system that we usually use in Formula type of vehicles. Okay, in Formula type of vehicles. Okay, ठीक है. So let's move forward. Independent type of suspension system. Now, even in the independent type of suspension system, there are plenty of suspension system that you can use in your vehicle. At this particular lecture, I'm just going to talk about the double wishbone arm lecture. Double wishbone type of suspension system, or you can simply say A-arms, or you can simply say control arms. Anything that controls the motion of your tire in the mini transverse direction is regarded as the control arm. So let's move forward. So if this is my chassis frame structure, this is my tire. Now my tire is having this particular hub or knuckle. This is connected with my chassis frame with the help of two arms. Now this arm is making a pivot point here. P1, pivot point here. We call it the hard points. These particular 2 points, P1 and P2, are regarded as the hard points. Okay, now you can see about this particular thing, or simply just say here, this is my tire, this is my chassis frame structure. Here, I've connected a pivot. If I connect a pivot, so what will happen? If I move my tire upward, it will move up, it will move down about this particular axis, about this particular point, right? About this particular point. So if I say, see, if I want you to track the motion of my tire, how will you do that, my dear friend? How will you do that? Let me change the ink. Okay, now see, this is the tire contact patch. Now, my dear friends, I'm talking about the tire center contact patch. I'm not saying the tire center, I'm saying tire center contact patch. Okay, so this is tire center contact patch. Now look here. If I say you need to track this particular point's motion, it's very difficult to track the motion of the complete tire. We need to have the point about which the complete motion is needed to track. So let's just track the motion of the tire center contact patch. So this is the pivot point about which my tire is it is moving up and down. So this is the pivot. Do it like this. Okay. So if it is moving up, if it is moving down, so once you have a kind of circle feedback, if it is moving down, it will move down along this way. Okay. So this particular thing you are looking up is the arm that is causing the motion or the movement, or you can say this is the radial arm. So what we find out from that when the tire is moving up, say for example, let me just do it again. Connected it like this. Okay. Now when I move it up, okay, say for example from my hands I'm trying to move it up. Will it move up straight? No. It will move making this particular inclination, this angle theta. And this angle theta depends on what? This angle theta depends on this particular length, my dear friends. It will move radially upward. When it will move radially upward, this is the front view, right? It means it will have the camber in. It will have the camber in. Now what will happen? See, if this is the case, this is just one single arm which is connected with my vehicle. If it is just this particular single arm, then what will happen, my dear friends? It will move up indefinitely to this particular limit. I want to limit its motion, right? If I want to limit its motion, I can use a suspension strut. Now the suspension can only compress by 5 inches. So after moving, when I move it upward, after the time at which it compresses completely by 5 inches, my tire will not move upward and it will create a restricted motion. It will create a restriction in here. It will create a restriction in here. So no dampening of force will happen after that. Now there is one thing. If I am just using a single arm, can I control this particular negative or positive camber that I will be getting in any particular case? I cannot much control it. So what I will be doing, I will be using the lower control arm. This is regarding the lower control arm, and I will also use the upper control arm, just like this. Now you can see if this is the longer arm, if this is the longer arm, lower control arm is the longer one, and the upper is the shorter one, the upper arm is going to restrict the motion of the longer arm, the lower arm. Okay, one of the arm is going to restrict the motion of the other arm. Moreover, in such scenario, you will be having more control. You will be having more control over the motion of the tire when moving up and moving down. Moving up and moving down. That's why people prefer to go up with the upper control arm and lower control arm mechanism. Now, again, this particular point, this the axis that is passing through it, this is the steering axis, the kingpin axis. From the front view, you will get the mechanical trail. From the side view, you will get the caster trail. Caster trail and camber trail plays the effective role in finding out the torque that is required to turn the wheel, to corner the wheel, or the torque that will cause the self-steering wheel of it. I don't want to get into the intricacies of that thing, but just understand it. So this is how you need to target your suspension system. Now, look here. Front view. This is one tire. This is another tire suspension system. Okay. When a vehicle is moving forward, you can see these arms can be equal in length, can be parallel to each other, can be unparalleled to each other, can be unequal in length. Okay. So the conditions are the upper control arm is equal to lower control arm, and upper control arm is parallel to lower control arm. Upper control arm is equal to lower control arm, and the upper control arm is not parallel to lower control arm. Or say upper control arm is lesser than lower control arm. Upper control arm is lesser than lower control arm in length, but the upper control arm is parallel to lower control arm. The upper control arm is not parallel to lower control arm. The condition could be the upper control arm is greater than lower control arm, but the upper control arm is parallel to lower control arm, or the upper control arm is non-parallel to lower control arm. 8 different conditions of how you arrange the suspension system. Each of these things will provide different results, different outcomes on how your suspension is going to behave. How? Now, these are equal and parallel, or unequal and parallel, whatsoever is the condition. If I extend these two together, these 2 points together, this particular point is regarded as the instantaneous center. If I do here, again the instantaneous center. We call it the front view swing arm. We call it the front view swing center. And this distance here is regarded from the center of the vehicle, the contact patch to contact patch, this length center. This length is regarded the front view swing arm length. Now, what do I mean by this? How my vehicle will move up? When my car is moving up, it is moving up along this particular point. Now see, here, when I was just having a single arm, I move it 1 inches and the replica here is 1 degree, very high. But here, I move it by 1 inches, the replica here is 0.5 degrees, 0.1 degree. More control. So you can see this thing. Generally, in the case of Supras, you have got parallel and equal arms. So this is how you do it. Okay, now one more thing. See, these 2 arms are connected together. If I make the center contact patch, if I join the center contact patch here, I join the center contact patch here. This particular intersection is regarded as the roll center. This particular thing is regarded as the roll center. You need to do the same thing for the sideways as well. So here I am just analyzing the transverse motion. In the sideways, you can again analyze the transverse motion, but on the basis of different outcomes of forces. What do I mean by roll center? What we got from here? This is the tire. I know the tire. You can consider that this point of the roll center is the pivot point about which my tires are rotate. Sorry, about which my tires will be reciprocating to any change in load. Okay, my tires will be reciprocating to any change in load. So if it is moving upward, the dampening force is acting at this particular pivot point, having this particular suspension stiffness. What this particular suspension stiffness is, my dear friend, it is not the strut stiffness, it is not the spring or the damper stiffness. It is the stiffness of the suspension system. What is the suspension system in here? The last topic. Okay, these are control arms. I'm using the suspension here. I say the stiffness of the suspension is 20 Newton per millimeter, for example. Now the force here acts is 10 kg, or say 100 Newton. Now, if it is 100 Newton, the spring should have to compress by 5 millimeter. Is it going to happen? No. This 100 Newton force, we all know this thing, force is reciprocative in nature. It will move here like this. This is a normal force, 100 Newton. But the only thing is, as you can see, there's a pivot point attached. So what will happen? The force that is acting here 100 Newton, the force that is acting here 100 Newton, and the force that will act here, say for example Fs, is going to be different. What is going to be the value? 100 Newton multiplied by this length, which is x, and this is y. Multiplied by x is equals to Fs into y. So Fx will become 100 into x upon y. I need to calculate all these distances from the pivot point. This is a pivot point. So the effect of this particular force on this particular pivot is 100 into x. The effect of this force on this pivot is Fs into y. So Fs will become x upon y. So for example, if distance is 5, this overall distance, and this distance is 2.5. So 5 upon 2.5, it will become 200 Newton. Okay. So now you can see this is my suspension. Changing the color of my pen. The force acting here is 200 Newton. I applied the 100 Newton. The acting force, vertical force is 200 Newton. But to compress the spring, I need to have this particular force. And this particular force, my dear friend, will become Fs divided by cos theta. Theta is the angle. Say for example, if this is at the angle of 60 degree, then it will become Fs is equals to, Fs by cos 60, 200 by cos 60 is 1 by 2. And say for example, the force that is acting here is Fs actual is equals to Fs actual. Fs actual will become 400 Newton. 400 Newton. It means the spring compressed by how much? 20 Newton per millimeter, right? Fsa is equals to stiffness 20 Newton per millimeter into compression. X is equals to 20 millimeter. So if I say what is the stiffness of the suspension system, I can say at 100 Newton spring compresses by 20 millimeter. At 100 Newton spring compresses by 20 millimeter. So the new stiffness becomes 5 Newton per millimeter. So this is the stiffness that we need to write here. The suspension system stiffness. And accordingly, you will be finding out how much your tire will, at what force, not just at the distance. I apply 100 Newton, how much will my tire move up? How much will my tire move down? At what angle will it, at what camber angle will it be having? What camber angle will it be having? My dear friends, you can do the same thing for the texture. I hope this particular session has given you the bit of understanding. I know this is not complete. If I just talk about the formula spring suspension system, this will take me at least 10 hours or 20 hours just to explain this particular thing completely. But I want you people to have the basic understanding. Someone who knows nothing about the suspension system, and you have been given this target, how do you start designing it? What parameters that you people need to remember while designing the suspension system for your vehicle. So thank you so much everyone for joining in. Please spread this message. If you have not subscribed our YouTube channel, please give us a subscription so that we can come up with more content. You will be having more knowledge about the subject. Moreover, it will also help us in growing. further. So thank you so much everyone for joining us. If you have got any question, any doubt associated with the discussion that we have made today, if you want to join any of our paid workshops or team workshops, any of our team workshop program, or if you want to join any of our internship programs, you can simply drop me a WhatsApp text at this particular number, 8800219630. My name is Abhishek Jain. You can find me on LinkedIn. Give me a follow in there as well. So thank you so much everyone for joining me. Thank you so much.